So let us continue now our discussion. All right. So can you guys see my screen?
Yes,
Yes,
we
sir.
can.
Okay. So again, the fifth formula or rule is the derivative for each term or each expression or each part. Okay. So again, this one is a constant, variable, and then exponent. This is a variable and then exponent. This is a constant and variable without exponent, and this is just a constant. So it's like a combination of from 1 to 4. Okay, this number 5. So 2x cubed, again, we just bring down we can go straight here. We can bring down the 3, okay, and then retaining the 2 in there, and then reducing the exponent by 1. So as a result, this would become 6x squared. Okay? So if you want to make it in a proper way, you can actually place it into something like this. So you are now deriving, or you are now changing the y in terms of dx. So we call that one dy over dx. Okay? And then we are now deriving each expression. So derivative of 2x cubed minus derivative of x squared plus derivative of 3x minus derivative of 2. Okay, so once you're done deriving, this is now the format that you will have after each expression. So 2 times 3 is 6. X raised to 3 minus 1 is x squared. For the second one, the derivative of x squared, so the same thing, we just bring down that exponent and then we deduct 1. So negative 2x, x raised to 2 minus 1 is negative 2x. For the third one, the derivative of 3x is just simply 3. Okay, so copy as it is. Derivative of any constant is 0. Okay, so plus 0. And then as your final answer, it's dy over dx is equal to 6x squared minus 2x plus 3. Okay, so were you guys able to get this one?
No, Engineer Daniel, can you please explain how did the 3 come from? Like the 2 multiplied by 3?
This one? Okay, let's go back
Yes,
to the derivative.
variables,
This one.
derivatives.
The formula number 4. Okay, so in here we have a constant, variable, and then exponent. Okay, that is the format that we have in here if we are going to compare. Constant, variable, and then exponent, correct?
Yes,
Okay, now notice that this one is equal to constant. Okay, that is the constant, and then the n was brought down. Okay, this n right here was brought down.
but,
Okay,
yes,
I will write this my. Okay, this n right here was brought down. Okay, this n was brought down. After bringing it, of course, you have to bring it down first. Okay, bring it down first before deducting 1. Okay, after bringing that one, that n, so you can now deduct 1 to your n in here. Okay, so that is why in the example, okay, we have an example here. So we have constant, variable, and then exponent. So first, we bring down the 3, okay, which is now this 1, as you can see. So the 2 is
yes.
still here. Okay, we just
But
bring
we
down the
brought
3.
down the 3.
Yeah, we brought down the 3. Okay, so this is our
Okay,
exponent we brought down. And then afterwards, the x is still x, so nothing has changed. Afterwards, we deduct 1, or
from
we
the n.
reduce the exponent by 1. It's n minus 1.
Mhm. Okay, I get it now. Okay, okay.
Okay,
Thank you.
all right, all right. So that is why this one here Well, actually, this one is similar. This one is the same example. Okay, the example here was the same with this one. Okay, so that is why we have the same answer. We just brought down the 3. So 2 times 3 is 6, and then we less 1 in our exponent. So it's x squared. Okay. So any other question or clarification for this example?
No, sir.
No, sir.
Okay, so let us have more example. Okay, so this one. Okay, so again, if we are going to derive this, so it's only proper to write this one into dy over dx. So it's like changing y in terms of x. Okay, dy over dx, and then is equal to the derivative of x squared plus 4, derivative of 3x squared minus 1, minus the derivative of 2x plus 1. Okay, it's like just placing d for each term or expression. Then afterwards, we can still distribute. Okay, so distribute the d to each expression or to each term in here. So derivative of x squared, derivative of 4. Okay, next one is the derivative of 3x squared, and then derivative of negative 1. Okay, followed by the minus derivative of 2x, and then minus derivative of 1 again. And then we can now perform derivation for each term or expression. The derivative of x squared is just simply 2x. Okay, we bring down and then we reduce the exponent by 1. Okay, so it's now 2x raised to 1, or just simply 2x. Okay, so were you guys able to follow?
Yes.
Okay, very good. Derivative of any constant is 0. Derivative of 3x squared is we bring down the 2. Okay, so 2 times 3 is 6. And then we less 1 to our exponent. So that's now 6x raised to 1, or just simply 6x. Correct? Then afterwards, we derive the constant again. This is 0. And then we derive 2x. Okay, so it's 2 only. Okay, or negative 2, because we have the negative sign in here. And then derivative of again of another constant is 0. So the final answer is 2x plus 6x is 8x minus 2. Okay, so are we
Okay.
clear?
Yes,
Yes.
sir.
Okay, very good. Okay, so this one, the derivative of, let me just, there we go. So the derivative of variables or functions that involves radical or rational exponent, like for example, the derivative of square root of v is equal to the derivative of v square root of v. Okay, so just memorize this formula once you encounter this one. Okay, so this is the same as derivative of v raised to 1/2 is equals to the derivative of v times v raised to 1/2. Now, for you to understand this one, let us have an example. Okay, so we have here y is equal to the square root of 4x squared. Okay, so this one is equals to 4x squared raised to 1/2. Correct?
Yes.
Square root of x is equals to x raised to 1/2. So this one, it's complete square root. Okay, it's not just the 4. Okay, it's the square root of 4x squared. So this one is equals to 4x squared, and then the square root is 1/2. Okay. Now, another thing that for that one. Let me just erase. We would have a better solution and a clearer solution. So in here, we can now derive this one. Dy over dx is equals to the derivative of 4x squared square root of 4x squared. Okay, so this one is equals to, so that we derive 4x squared as it is, which is now 8x. Okay, we bring down the 2, so that's 2 times 4. We reduce the exponent by 1, which is 2 minus 1, so it's 8x. And then square root of whatever your v is, okay, which is 4x squared. Okay, so the derivative of v is this one. Okay, not maybe not the one. Is this one. Okay, once we done deriving this one, you will have the 8x as your answer. Okay, and then whatever your square root of v, okay, so just copy it as it is, no changes. Okay, which is now this one. Okay, so are we clear? We only derive that is the one that is inside, and then we copy. Okay, we copy that one square root of 4x squared beside it. So that is already the final answer. This one. Okay, so once you saw something like this, we derive whatever is the one that is inside, and then we copy this one and then place it beside. Okay? Ano tita? Sige lang tita, nagkaklase pa ako. May klase pa ako. Okay? So are we clear?
Clear, yes.
Yes, sir.
All right. So I guess that's already the end of the module 1 to be exact. Yeah, there is no more. Okay, so we will stop here for now, and then we will just continue the rest next week. Okay, during our face-to-face. So anyone who has a question or clarification so far before we end our meeting for today?
No, thank you.
Okay. All right. So if you don't have any questions or clarification, you guys may now go, and see you guys next week.
Thank you, sir.
Okay.
Thank you, sir.
All right.
Thank you, sir.
Thank you.
Thank you, sir.
Okay. Thank you, Tati. Bye.